All right, lesson 3.5, scatter plots and lines of fit. So the essential question for this lesson is, how can you use a scatter plot to describe the relationship between two data sets? So when we're talking about scatter plots, basically we have data from two variables that is not necessarily going to be a perfect linear function or a perfect any other kind of function, but we can generally describe the relationship because the lines are in, or the dots are in some sort of pattern. With that, we're going to talk about three vocabulary words. The first one is association. Now, the association is the relationship between X and Y values. Okay, and we can have three different types of association. And that describes the three different kinds of relationships that we can have between the X and Y values. We have a positive association, which means that Y increases as X increases. So as the X values get bigger, the Y values also get bigger. We have negative association, which means that the Y values decrease as X increases. So as the X values get bigger, the Y values get smaller. And then we also have no association, which means there's no relationship at all between the X and Y values. That would be something like the number of days a week you eat 3 meals and the amount of exercise that you get. Those will have no bearing on each other really, because you can decide to exercise whether you eat 3 meals or not. And then we have correlation. Now, once we have association, we get a little bit more specific. So if we see some sort of association between these X and Y values, we then can decide if those values are correlated to each other. And that means that the data suggests a linear relationship. So correlation is when the data suggests a linear relationship. So those data points are not exactly a straight line, but we could see that they are kind of moving in that straight line, and we could probably represent it with a linear function. And there are two types of correlation. Obviously, if there's no association, then it's not going to be correlated. So we have a positive correlation and a negative correlation. Positive correlation is when the function is increasing, and a negative correlation is when the function is decreasing. Okay, and down here I'm going to show you a couple of examples of scatter plots, and we'll talk about whether they are associated, correlated, and so on. And then the last vocabulary word is trend line. So once we find out that the data is associated, and then we can say, oh, it's correlated, it looks like it's a linear relationship, we can draw a trend line for the data, and a trend line models the data in a scatter plot by showing the general direction of the data. We can say it fits the data as closely as possible. So I'm going to draw some scatter plots down here. And we're going to talk about whether they are associated, correlated, and if we can draw a trend line. So if I'm looking at just the association at this point for these graphs, I can see for sure that this scatter plot is definitely scattered all over the place. There's no relationship there between the X and the Y values. So I'm going to say this one is no association. Whereas these two, I can see a general pattern. This one is going up and to the right. So as the X values are getting bigger, the Y values are also getting bigger. So that is a positive association. And this one looks like it's going down and to the right. So as my X values are getting bigger, my Y values are getting smaller. So that is a negative association. Now, because there's no association on this one, we don't even need to talk about correlation, but these two have association. So now we need to decide, does that look like linear? Does this look like it could be modeled by a straight line? Yeah, totally. Same with this one, but it's one of them is positive correlation and the other one is negative correlation. Then we need to decide what our trend line is going to look like. So basically our trend line is a line that fits this data as closely as possible. So basically we want to look at the data points, and I'm going to use a ruler at this point, and we're going to try and figure out whereabouts can we draw this line so that there's an even number of points above it and below it. So I'm going to just do a little bit of eyeballing. Looks like that spot right there is pretty close. So I'm going to draw that trend line. Notice I have 1, 2, 3, 4, 5, almost 6. 1, 2, 3, 4, 5, 6 dots on either side. So you want to try and draw that line so that there's an even number of dots on both sides. And nobody's going to draw the same exact trend line for every single graph. And so the idea is that you are drawing a line that models it as best as you can. Okay, so now that we know this background info about scatter plots and trend lines, we're going to actually make one, and we're going to write a trend line for that data. So what I have here is the speed of the internet in megabytes per second. So 35 megabytes per second, 40, 45, 50, 55, 60, and then the amount of time it takes to download 100 megabytes, and this is in minutes. So if my internet speed is 35 megabytes per second, it's going to take 6.65 minutes to download 100 megabytes. So go ahead and pause the video and write that table in your math journal, and then we're going to make a graph where the X is the internet speed and the Y is the time to download. And my time to download goes up to about 7 minutes, down 3.8 minutes. So I'm going to just go by ones. And my megabyte speed goes from 35 to 60. So I'm gonna go by 20s, or I guess I'm gonna go by 10s, but only label every 20. Now, when I graph these data points, I'm going to make a scatter plot. So that means they're not going to be perfectly lined up in any sort of pattern, but we should be able to see this linear relationship because we're going to make a trend line out of this data. So my first data point is 35 and 6.65. So I'm going to find 35, and then I'm going to go up to 6.65. It doesn't have to be perfect because, again, it's just a scatter plot. Then I'm going to go to 40 and graph 5.82. 45. And some of my dots, again, are not perfect. They look like they're really close to each other. That's fine. Okay, and I'm going to actually zoom in just a minute. So my first step is to plot the points to make a scatter plot. And then once we do that, we're going to draw our trend line. Now, when I do that, I'm going to do that same thing. We want it to fit the data as closely as possible. And so when I draw this, I kind of want to make sure that I have the same number of dots on either side. So I'm going to actually draw it so that it goes through these two dots. Okay, now, once we get our trend line drawn, we're going to basically write an equation using this green line that we just created. So we're going to pick 2 points on the lines. That's very important. It has to be on the line to write your equation. So when you draw your trend line, if you pick points like this, that's not actually on your trend line. So that's not going to help you write an equation for this green line. So I'm going to pick 2 points that are on that green line exactly. And just so happens that I maybe did that on purpose, where I have those 2 points on the line. And they're actual data points from my table. So I'm going to pick those 2. So this one is 40, 5.82. And I have 55 and 4.23. I'm going to zoom back out. And now I'm going to use those 2 points to write my equation. So in order to write an equation, I need to have the slope. So I'm going to label x1, y1, x2, y2, and I'm going to find the slope. When I find the slope, I do y2 minus y1 on top, so 4.23 minus 5.82, and I divide that by x2 minus x1, so 55 minus 40. And when I simplify, I get negative 1.59 over 15, and that simplifies to negative 0.106. Now, usually I say leave the slope as a fraction, but 1.59 over 15 is kind of crazy. And with this situation, we actually want to think about that as like the amount of time that it goes down as your internet speed gets higher. So it's going to go down by 0.1 of a minute as my internet speed goes up. So I can think of it like that. Now, because I have the slope, I need to figure out what my y-intercept is. I'm going to use one of these points and that slope in point slope form, and then I'm going to solve to get slope intercept form. And I'm going to use the point 40 and 5.82. So y minus 5.82 equals negative 0.106 times x minus 40. First thing I need to do is distribute. So I get y minus 5.82 equals negative 0.106x plus 4.24. And then I add 5.82 to both sides. And I get y equals negative 0.106x plus 10.06. Now, remember I said trend lines are not always an exact fit for the graph. So if I just want to look at it and see what it looks like compared to my scatter plot here, if I were to look about where this green line would cross the y-axis, it actually looks like it's going to cross a little bit below 9. But my y-intercept here is 10. So it's kind of telling me that my trend line maybe isn't the most accurate line because my equation here is a little bit different than that, but that's okay. The idea is the trend line is not going to be exactly what your equation is, and that's fine. So just know with trend lines, you want them to be really close to what your data looks like, but it will not be specific. And that is 3.5.